Welcome back, ladies and gentlemen. Today's section is 11.5, the area of circles, and along with it, the area of sectors. As usual, here's your exit question at the top of the screen. To get us started, I'm actually going to reference you over to another video because it has all the graphics that I wanted to create and it was done very well. It goes a little slow, but it works. So please click the link below to go to a different video and then come back to me. Okay, after that video, we know where the area formula comes from. You do need to memorize the area of the formula for the area of a circle. It is pi r squared, and when you calculate this, you use the pi button on your calculator and you try to give your answer in exact form whenever it specifies for you to do so. Remember to use the pi button on your calculator because that will give you a more precise answer. The thing that the video did not talk about was the area of a sector, and the area of a sector is simply a portion of a circle. So we can define a sector by its central angle, and that central angle will be some portion of 360. So the measure of whatever the arc is that goes along with that sector, and then the area of the sector will be a portion of the area of the whole circle. So this is the portion of the circle area, the area of a circle, and this is the whole area of a circle. And by setting up that proportion and solving, you should be able to get anywhere you need to go. You can also phrase it just like this. The area of sector APB is a percent basically of the circle. Okay, why don't you pause the video and see if you can figure out the exact area of both big and small sectors. Exact meaning that you have to leave your answer in terms of pi. No decimals, no rounding, no truncating. To get yourself started, you have to set up two proportion equations. One that talks about the large section of the circle, which would be 290 degrees, and one that talks about the small sector. So we talk about the major arc and the minor arc over 360, and then the area of the blue sector versus the area of the pink or red sector. So you plug in a number right there, that'll be 70 and 290 respectively for the small and big triangle. Now down on the bottom we had pi r squared. Our radius for the circle was 8, which when squared turns into a 64. So down on the denominator of one of your proportions you have 64 pi. I did not convert to a decimal here. I'm just using the pi symbol, just carrying it right along with it. From here on out we do cross multiplication. So we're going to take 70 times 64 and 360 times y. Here we've got 290 times 64 and 360 times x, which looks like that. So you get this giant number, and since we're not really going to go all the way to a decimal, we're going to keep it as a fraction. You might have opted just to keep it as 70 times 64 times pi. That would totally be an option, so that when you then divided by 360, it would be easier to simplify the fraction. But either way, to solve this equation on either side, left or right, you would divide by 360. When you do that, your calculator will spit out a decimal. So you need to be aware of that. And we're kind of ignoring the fact that the pi is there. We're just interested in getting 4,480 over 360 to be in simplest form. When you type that into your calculator, you get a decimal. You can use the conversion button on your calculator to convert that decimal back into a fraction. Or you can simply just start chopping each number in half or finding common factors of top and bottom. Eventually, you'll get down to, for this one, it's 464 over 9, and for this one, it's 112 over 9. And again, we were just trying to simplify the numbers with relation to each other, and then that pi will just continue to hang out up on top. So this is 364 pi divided by 9 units squared. Also, don't forget your units. There were no measurements given to us in inches or millimeters or whatever, so we have to use the generic units squared. Here's your homework assignment. I'll see you next time.